Excel Tips. My name is Neil Blackwood, and in this video we're going to be looking at how we can create a custom function to create a loan schedule. Now at the moment we're looking at a loan schedule that's created using a few formulas, and the final output that we're after is a single function that takes 4 inputs, and it also creates a loan schedule. So let's have a look at where we're going, which is in this sheet. So what we have here is in cell A11, here is a single function called fn loan. I use a prefix of fn lowercase for my custom functions, so I know it is different to a built-in function. And it takes 4 inputs, that's these yellow cells here, and it is generating a multi-column report that is creating a balanced, gets down to 0, loan schedule. And it's flexible, so we can change the number of periods here, and if we go down to the bottom, you'll see now we only have 240 periods. Okay, so how do we do this? Let's go back to our original sheet. What we want to do is convert this multi-formula schedule into a very complex formula. The idea behind this is if you have a report that does take a lot of effort to create, what you can do is you can capture all of the formulas in one large formula and then convert that large formula into a custom function. And so that's what I wanted to take you through. So this example has 7 separate steps. I've numbered these sheets for each of the steps that we're going to take, and I'll take you through, and initially I'll show you what the formulas are doing on this sheet, and then I'll show you how we develop the large formula that will eventually become a custom function. The standard layout for the schedule is that we have a month number, we have the month, the repayment, interest and principal, finally ending up with a balance. Now, each of these cells in row 11 has a function that spills down. It's pretty much all controlled by the sequence function that is in A11. Now, I have covered dynamic arrays and a lot of these formulas in previous articles, so you can do a search on the In the Black website. Let's start with the PMT function. So this calculates the repayment amount. So the PMT function takes the rate, so that's the interest rate, so that's the amount we're dividing by 12, the 6%, and then we're multiplying by 12 the number of years. Okay, so we're converting these entries into monthly figures, and B2 is the loan amount. I've also included a start date here. That's not really required by the formulas, but it allows us to create our schedule. Okay, so that is our monthly repayment calculated. From there, we can then create our month number. I'm starting at 0. The sequence function creates sequential numbers. And again, because we are looking at this monthly, we're multiplying the years by 12, and I'm also adding 1. Now that's because I want to start at 0, and so the sequence function has an option that lets you specify the start, and so in this case we're going to start at 0, and in this case go all the way to 300. Okay, so that's the sequence function. The EDATE function allows us to convert the month number to an actual month, so we've got a start month here, and this is where the loan's taken out, and then the month after that is when we have the first repayment. There is a bug when it comes to dynamic arrays and dates. So let's show you the bug. That formula was working, and all I did was take the plus sign away from this reference. Unfortunately, when you're working with dates in dynamic arrays, this is a bug that's been around for ages, it hasn't been fixed yet. You will often get an error when you are using in this case, the sequence function to increment a date. Now, you can do a calculation like +0, and that will fix it. You can also just put a plus sign in front. It doesn't really make much sense, but it works. And there we go. So that's a bug when you're working with anything that's relating to periods or dates and you have a spill range. All you do is put the plus sign in front of it and that fixes it. Hopefully Microsoft will fix this bug eventually. Okay, so that gives us our months. So when you're referring to a spill range, you refer to the top left cell reference and put the hash symbol on it. And that refers to that spill range, which is spilling down. Just a reminder, a spill range has only one formula in it. It can spill down and across. All of these formulas are spilling down. Okay, so if you click in the next cell, you'll see the formula is grayed out. Okay, so these cells need to be empty underneath. Okay, the repayment, basically we're checking cell A11, and if it's 0, we're going to display 0. Otherwise, we're going to use the B7 amount. You'll notice there's no dollar signs required here because it's a single formula. It just works. You don't have to worry as much about dollar signs when you're working with dynamic arrays. The next calculation is the interest. This one looks a little bit scary. It's the same if function, but the calculation is using a function called cumulative interest payment, and it's shortened. And this one calculates the interest for a specific period when you are using the PMT function. So it takes the same 3 inputs as the PMT function, and it has 3 extra inputs. And again, you can see that plus sign in front of the reference to A11. So basically it's saying, just show me the interest payment for that period. So whatever period's in the same row, then just show me that. The comma 0 is required for the type of payment. Now, there is an identical formula for cumulative principal. It's exactly the same formula, but it calculates the principal component of the repayment. Finally, we have a calculation of the balance. The scan function is a little bit different in Excel. I have covered it previously. It does allow you to have an initial value and then a spill range. And then you can do a calculation using LAMBDA to capture the initial value as X. The spill range is Y, and then you can do a calculation. Now, this does a line-by-line calculation. What happens to the value for X plus Y? It gets put back to the value for X as the starting point. So it's perfect for running totals, which is what this is doing. So the effect is we start off with the $500,000 and then we reduce the amount by the principal, which is the E11 reference, and so the principal slowly reduces the balance until we get to the bottom and we have 0. They are all of the entries for the schedule. There are some just straightforward sum functions that are adding up the total repayment, total interest, and the principal. The interest gets a bit scary when you see how much interest you pay over 25 years. But that's it. So they are all of the formulas. Now, what we're going to do is step 1 is we're going to start creating the mega formula that's going to capture all of these in a single formula. Now, it can be a little bit daunting, but if you consider it like programming, it becomes a little easier to understand. So let's have a look at step 1. What we're going to do is we're going to build up the formula pretty much column by column, and we'll start with the easy part. We're going to use the let function. So the let function allows you to use variables in the calculation. After you have the let open bracket, now I've used separate rows here for each variable. That's sort of best practice in displaying the formulas. It also makes it easier to understand. Now, what's really important here is to make sure the formulas are all complete and you've put the commas in, because the commas are really important. Now, to get the line breaks that I've put in here, you use Alt-Enter. Hold the Alt key and press Enter, and that, as you can see, puts a line break in. Variable S is going to capture all of our sequence. So our sequence number pretty much drives a lot of the calculations, and we're going to capture that in the variable S. We're going to calculate our month in the MTH variable, and we're going to calculate the repayment. Initially, we're going to use that B7, but we are eventually going to calculate that separately. But we're just going to use that to start with. So there's our B7. Now, the HStack function is really powerful. What it does is it allows you to build up a two-dimensional spill range by combining columns. So I'm combining the sequence numbers with the month names with the repayments. So this formula creates a 3-column report that we can see here. So month number, month name, and the repayment. So that's the starting point for our formula. And the let function allows us to build it like that. Again, make sure when you are using this layout to have a comma on the end here, and that allows you to then put the Alt Enter, and you can have another name. Now I'm using shortened variables. You could use longer variable names. It's sort of a trade-off between keeping the formula short and having the more descriptive names. So that completes step 1. We've got a 3-column report. So at the moment we're reliant on cell B7, which has a separate calculation. So we need to amend the formula so that it's self-contained and do that calculation within the formula. We need to basically convert this if statement into a self-contained calculation for the monthly repayment. So I'm going to do that with another variable. Okay, so let's go to step 2. I've created a repayment variable as opposed to repayments, which is the plural. And so I've calculated the value that was in B7 and captured it in this variable, and basically just replaced that B7 reference here with the repayment itself. So I've captured that calculation here. So now this formula is self-contained. I don't need to refer to another entry. So for example, in this one, I can now delete that cell and this will still work. Okay, so we've created a self-contained 3-column formula. Let's add the interest in. As you can see, it's getting quite long. And what we find is as we build out our formula, the PMT formula and the cumulative interest formula as well, they need pretty much the same things, as well as when we're going to do the principal as well. What we're going to do is we're going to capture the number of periods in a variable. We're going to capture the interest in a variable, so we're just dividing that by 12. And we've put them at the top. And then from there, we can then replace all of those references to the cells with our extra variables. So PER plus 1, and then we've got IPER, and then we've got another IPER. So the goal here is to capture a calculation once and then reuse it using the variable names. This helps with maintenance as you only need to change the calculation in one place. I've added a variable here to calculate that cumulative interest and then added that to our HStack. So you can just keep adding to this HStack to keep adding an extra column. Okay, let's now have a look at the principal, which is pretty much the same sort of calculation. And I've also included the balance. So the principal, as you can see, it's pretty much the same formula. We just can copy that, and the principal is the variable name. We then need to calculate our balance, and so we can use the scan function. So all of these formulas are the same formulas that we looked at individually, and we're combining them all in a single formula. And again, we can add the principal and the balance to the end of our HStack. So we now have a working schedule of the values. Okay, so all of the values are here. But we're not quite there yet because we also want to include the headings. So let's see how we do that. So for the headings, so I've got a HDG, which is a variable, and to create the headings, you can use what's called array syntax. And it's basically just curly brackets or braces, and then you can create all of the headings separated by commas, which is what I've done, and close the curly brackets. So this creates 6 cells combined in a single row. So it's the heading row. As well as a hstack function which allows you to combine columns, there's also a vstack function which allows you to combine rows. So what we can do is we can put that heading variable above the hstack. Obviously, I've made sure that these are the correct headings. And there we have it. So you can see there's the heading row followed by our values. So this is the final formula that we are then going to convert into a custom function. So this, if you wanted to, you could use this as your formula, but that is very complex and it's not easy for other people to use. So let's make it easy for other people to use and for you to use. Okay, step 6. The LAMBDA function allows you to create a custom function. And what it does is it goes in front of whatever your complex calculation is. And what you can do is you can define arguments. So these are what will become the custom function arguments. We have an amount. I've called it interest underscore int underscore rate for the interest rate, the number of years, and the start. So they will be the 4 inputs that we want to have for our custom function. Now, to test the custom function, there is a different type of syntax that Excel is using. That is the LAMBDA function, all the way down to the bracket, but you'll notice there's another set of brackets or parentheses on the end. And they are the inputs to these 4 arguments. So B2 gets given to amount, B3 gets given to the interest rate, B4 goes to years, and B5 goes to the start. And then from there, those arguments are passed to our let function. So the years gets passed into the PER, the interest rate gets passed into the I variable, and the start goes to the MTH variable. So the amount argument will pop up a few times in the other calculations and down here for the scan. So all of those get passed to the let function. So the sort of sequence is B2 gets passed to amount, and then it gets passed into each of the times amount gets used in the formula. And this tests it, so we can make sure that this is working, which it is, all the way down to the bottom. So once you've tested your LAMBDA and make sure it's doing what you're expecting it to do, what we can do is then create a custom function. And to do that, what you do is you copy all of the entries to the end of the LAMBDA bracket. You don't include this testing section. Copy that, Control C. Now I'm going to go and create a second or another custom function. So under formulas, name manager, I'm going to create a new name. So I'll call this FN loan 2, and I'm going to paste that LAMBDA into this refers box. That's it. That's all you need to do. And click OK. So now I have a loan 2 that I've just created based on this LAMBDA. So I could go, let's close this down. I could go over here and I could say equals FN loan 2. There it is. And then just refer to that cell, that cell, that cell, and that cell. So the 4 input cells. And when I hit enter, it's going to create a loan schedule. It might not be formatted, but there it is. Well, we have the complex formula, we convert it into a lambda, and then from that lambda we can convert it into a custom function. This is the function in use here, so this is the one that I've created before, so fn loan, and as we can see, that is working. An extra step, I'll take you through in the name manager for loan, I'll show you this here and I'll zoom into it. An extra step is to add entries in this comment section. This is sort of like the documentation for the custom function. Because you are creating the function, you need to give the user a little bit of information. So that's what I've done in this section, and basically you just type it in. You've got to use Control Enter to put a line break in this section. So, and you've got to use the enter on the far end of the keyboard as well. So just a heads up, it's a little bit clunky, but you've got to type this in. And I'll show you why it's so useful. So let's create this from scratch over here. So if I type in fn, all of the reason I like to use fn is all of the custom functions in my files will display after I've typed in fn, and so they're all listed there. So the one I want is loan, and if it's highlighted, you'll see all of that information is displayed, or not all of it, but most of it. Also, the layout or the syntax is also shown: amount, interest rate, years, and start. If I double click it, notice that those arguments are listed. That's automatic. It always lists all of the arguments there. And so it basically helps the user use the formula. And again, we can just click there and create our loan schedule. This hasn't been formatted, so that's why it's got that number for the month. Now, I have included an extra version of the function. It's called total. This is the LAMBDA version of it. And what it does, it's got an extra row at the top. I haven't included this in the article, sort of restricted to how much we can get into the article. This one also has a total row, which I've added in. So we've added up everything. So that's the LAMBDA test. And then this is it in working. It's called loan totals. It takes the same input, but it includes this extra row at the top, which gives you the total for each column. Custom functions are really powerful. If you've got a complex formula, and we created a very complex formula, and we've converted that into a simple to use function that you can use in other files. So if you go in here and we go right click, move copy, we can create a copy of this sheet, put it in a new book. And what you can do is you can create, let's go over here. If I go equals fn loan, you'll notice that it doesn't give you all of the description. So one of the downsides with this, when you copy it to another sheet, is that you lose that documentation. It still works, but when you go and check the name manager, that comment has been lost. So that's one of the downsides when you are copying it. You do need to, if you want to include that commentary, you need to copy it across as well separately. So that's the only downside with it, and that's it. So that formula, that fn loan, is available in this file, and so I can create my own schedules in this file. Okay, so custom functions are really powerful, they're really flexible, they simplify complex things. So I've used a loan schedule as an example, but you could apply this to other types of reports that you might do on a regular basis, and you can sort of capture all of the logic in one mega formula and convert that mega formula into a simple to use custom function. Hope you found this useful. Thanks for watching.